Good day, everyone, and thank you for attending this session. My name is Fadi Masood. I'm a director in the solutions marketing team at Infinera. In the next 25 minutes, I will provide you with an overview of XR Optics and its applications. But before we do that, let's take a look at the current operational challenges. Demand for capacity is constantly growing, fueled by video streaming, cloud applications, enterprise migration to the cloud. We're also witnessing the deployment of fifth generation wireless or 5G around the globe. Deploying 5G is particularly putting a lot of pressure on the network. Various modeling exercises have shown that 5G will require between 10 times and 100 times more capacity from the existing network. 5G also requires edge computing, or what is called mobile edge compute, or MEC. These edge compute sites are smaller facilities located close to the edge of the network and to the devices that generate data. And by processing data and services as close to the end user as possible, edge computing allows organizations to reduce latency, deliver improved performance, and reduce transport costs. And the current challenge is where and how to deploy those edge compute sites with a minimum disruption to the network. Could some of these MEC sites be deployed at current network aggregation sites? However, most of these sites are maxed out when it comes down to space and power, as you can see on the right-hand side. Or build brand new MEC sites, but again, that also has its challenges because it requires CapEx, and available space, and power. The other challenge is how to provide connectivity now that edge compute sites are distributed across the network. So if I can summarize it in a nutshell, demand for capacity is growing, the architecture of the network is changing, and now let's take a look at how the current infrastructure can overcome those challenges. Since the inception of optical networking, there has been a significant misalignment between the actual traffic patterns and the technology used to transport that traffic. Network traffic patterns, especially in the metro, are hub and spoke, with numerous endpoints consuming traffic that is aggregated by a small number of hub locations. But if you double click on that, by contrast, optical connectivity solutions have been implemented using strictly point-to-point technology, where each end of the connection is required to operate at the same speed. So if you have 1 gig laser on one end, you have another 1 gig laser on the other end, 10 gig, 10 gig, 100 gig, 100 gig. And the result is an extremely inefficient transport architecture that requires a large number of bookended transceivers, as well as numerous intermediate aggregation devices to upspeed traffic flows. This problem has been solved in mobile networks, where there is a single radio at the tower that talks to many radios embedded in our cell phones. However, this problem still remains in optical networks, where each laser has to be bookended, operating at the same rate, requiring twice the number of transceivers. So if you have 16 endpoints, you need 32 transceivers operating in a point-to-point fashion. So this is too expensive and operationally inefficient. This is a snapshot of almost, if not all, aggregation networks now. So you have many endpoints generating traffic. Those endpoints are connected using point-to-point optics to an aggregation site, where switches and routers pack the traffic into a higher bitrate wavelength and then transport to the hub site. Again, the number of transceivers needed here is twice the number of endpoints, in addition to the electrical aggregation sites. This problem can be solved with XR Optics. XR Optics is the industry's first point-to-multipoint, direct low-speed to high-speed coherent pluggables, or the industry's first point-to-multipoint laser. And XR Optics allows a single 400 gig to connect simultaneously to 16 endpoints, providing bandwidth in 25 gig increments. And as a result, reducing the number of transceivers by more than 50%. You're going from 2 times n, where n is the number of endpoints, to n plus 1. And later on in the presentation, I'll show you a case study where the number of transceivers actually is being reduced by more than 50%. All bookended connections from endpoints at the aggregation sites can be replaced with a single pluggable 400 gig XR optics that can talk simultaneously to up to 16 endpoints. And the other point here is we're going from a chassis and transponder to a pluggable form factor. For example, a 100 gig XR pluggable at each end, and a single 400 gig XR pluggable at the aggregation site. This alone reduces the number of transceivers by 50%. In addition, there is a massive reduction in power and footprint, as these pluggables are way too compact and less power hungry than current solutions. XR optics utilizes digital signal processing to subdivide the transmission and the reception of a given wavelength spectrum into a series of smaller frequencies called digital subcarriers or Nyquist subcarriers. So these digital subcarriers can be independently managed and assigned to different destinations, enabling the industry's first scalable point-to-multipoint, as I mentioned, direct low speed to high speed optical connectivity. But as you can see on this slide, a single 400 gig XR optics at the hub generates 16 25 gig digital subcarriers. And one important point to mention here is one or multiple digital subcarriers can be combined and assigned to a specific destination to provide the required bandwidth. So that is key. The other point here is XR optics uses 16 QAM modulation, so it provides a very good optical performance than gray optics. So we can push this aggregation point deeper into the network all the way to the hub, as you can see here on the right-hand side, replacing boxes and boxes at the aggregation site with a simpler passive splitter combiner device. And this actually has a major positive impact on OpEx, as well as significantly simplifying the network. And XR optics transceivers are designed to be equipped in a wide range of networking equipment, including Ethernet switches, routers, wireless baseband processing systems, cable MSO, aggregation platforms, PON, hidden aggregation systems, data center servers and switches, and so on. And the other thing is XR optics meet the most common standard when it comes down to pluggables. For example, the same MSA standard in terms of physical form, QSFP28, CFP2, QSFP-DD, OSFP. And there's another advantage of XR optics is the flexible end-to-end management. So XR optics supports embedded communication channels to provide a complete and thorough management system between all XR optics modules, whether at the hub or at the endpoints. And this management system facilitates bandwidth allocation and the connectivity matrix between the different destinations, as well as managing alarms and network status, allowing XR optics to act as a sub-network within a much larger network configuration. Okay, XR optics also supports point-to-point application and supports multiple rates. So there's a 100 gig XR optics supports up to 4 Nyquist subcarriers, 25 gig each. Typically, those 100 gig XR optics are deployed at the edge. There is a 400 gig XR optics with 16 subcarriers that is typically used or deployed at hub sites. And later on, that 400 gig XR optics at the hub can be upgraded to an 800 gig XR optics with 32 subcarriers. So that's the key here, is you can upgrade the hub without upgrading the endpoints, because everything is based on a 25 gig currency, where that becomes the currency of the network. And that's what we call intergenerational networking, where you can have an 800 gig talking to the same 100 gig XR pluggable. So XR Optics supports point-to-point and point-to-multipoint applications. So let's take a look at the point-to-point. Okay, so XR Optics can be deployed in a typical ZR plus point-to-point applications. And in addition to the reach it provides for metro, regional DCI, or as a DCO transponder, XR Optics provides a lot of additional features and capabilities, such as the intergenerational networking, as I mentioned, where a single end can be upgraded to 800 gig, to hub, and without upgrading the entire network. So for the first time, you can have multiple generations of that optical engine within the same network. And for the first time, a node upgrade does not mean a network-wide upgrade. XR optics are also highly automated to accelerate service turn-up, troubleshoot, streamline operations. There are features like automatic wavelength assignment, automated power management, and many others. And XR optics also have many integrated functions that are key for quick troubleshoot and service turn-up, like, for example, OSA. Embedded OSA and OTDR, as well as many other system-level functions like integrated management and control plane. Optical performance is also an important attribute of XR optics, where, for example, a QSFP DD pluggable provides the same output power as a much bigger pluggable such as CFP2. Another key attribute I want to mention here is that XR optics can be deployed on a fiber pair and a single fiber working in a bidirectional configuration. This is key when for example, for some PON deployments. And off the same 400 gig XR pluggable, you can have a Nyquist subcarriers going to end locations over fiber pair. You can have Nyquist subcarriers going to another head end or set of head ends over a single fiber working. Traffic can be symmetrical. The same number of Nyquist subcarriers are going in each direction, or it could be asymmetrical. Let's say I have more subcarriers going downstream and I have less subcarriers coming upstream. So with all these features under the hood and the ability to scale capacity way beyond current deployed technology, the ability to assign capacity where it's needed and when needed through software, and providing an architecture that is future-proof, as I mentioned, the multi-generational aspect of XR optics. XR optics now makes it possible to extend coherent to the edge, to overcome all the challenges of relentless demand for bandwidth and the agility required for the new era of connectivity with 5G cloud applications and MEC. So now let's take a look at the application. So XR optics can be deployed in a wide variety of applications, from a typical point-to-point applications, the ZR plus type of application, metro regional DCI, to point-to-multipoint applications in a hub and spoke configuration for traffic aggregation in a metro or backhaul, PON overlay, like you see on the left-hand side. XR optics can be deployed over rings or horseshoe configs, as you can see on the right-hand side, where the traffic is replicated to two different hub locations. And the point-to-multipoint is key for traffic aggregation, as it eliminates the complexity. It can easily meet the requirements of the unpredicted connectivity in the network. with point-to-point connections, every time there is a change in the network, that triggers truck rolls, triggers manual intervention, especially when it comes down now, like with 5G and mobile edge computing. So XR Optics allows a dynamic capacity allocation, software configurable bandwidth. The point-to-multi-point aspect, it's way beyond the current generation of pluggables where it's only point-to-point. So XR Optics does point-to-point and point-to-multipoint and allows an efficient and scalable deployment of 5G and MEC and DA and so on. So what are the benefits of deploying XR Optics? So let's take a look at this animated slide. So XR Optics dramatically reduces CapEx and OpEx. So first, by reducing the number of transceivers by 50% and eliminating the numerous intermediate aggregation sites. This provides a simpler architecture, a much leaner, simpler architecture that helps reduce latency, which is key in 5G. XR Optics is also a coherent technology, so it allows network operators to turn up way more capacity on existing fiber, way more than direct detect, for example. And XR Optics also allows an efficient utilization of routers by replacing the numerous low-speed routers by much denser, more compact, and higher density routers with 400 gig ports on the client side and 400 gig ports on the line side. As you can see on the right-hand side of this slide, XR Optics also accelerates capacity turn-up, reduces truck rolls. Now, let me give you an order of magnitude of how XR Optics can reduce CapEx and OpEx and simplify the network. Okay, so this is a real diagram showing the connectivity from a radio unit on the left-hand side all the way to the data center, going through the aggregation sites, the spine and leaf architecture, the edge router, and so on. In real life, a circuit has to go through 52 transceivers in 26 different network elements. If we transform this architecture with XR Optics, XR Optics reduces the number of transceivers from 52 to 7 and the number of network elements from 26 to 4. And for any network operators, eliminating such a large number of transceivers and their boxes frees up a lot of space and power to scale for 5G and MEC deployment, as I mentioned. One of the main challenges I mentioned early on is where to deploy those MEC sites. Most of the sites are maxed out. You need to find space and power. So a lean architecture enabled by XR Optics allows network operators to free up a lot of space and power. So this is key. I mean, as 5G triggers 10 times and 100 times more capacity, network operators cannot scale their space and power by the same percentage, by 10 times or 100 times. Hence, freeing up space and power while increasing network capacity, it becomes paramount. Increasing capacity is important, but what is equally important is how this capacity can be used. So XR Optics allows a dynamic allocation of capacity, where capacity at each site can be individually and dynamically increased with additional subcarriers, basically matching the provided capacity with the real demand. So as you can see on the slide here, 3 areas: business area, 25 gig day one; residential area, 25 gig, single subcarrier; and entertainment area, 25 gig. So we can increase the capacity of any endpoint by assigning one or more additional subcarriers. So in this particular case, sending another subcarrier to the business area, doubling the bitrate from 25 gig to 50 gig. And for the residential area, everybody's working from home. Now we're increasing the capacity from 25 gig to 75 gig. So one thing I want to mention here is increasing capacity in one area of the network does not impact the rest of the network. Now, capacity can be assigned and reassigned based on the time of the day, the time of the week, the time of the month. So capacity can be shifted remotely and on the fly from one area of the network to another where an extra capacity is needed. Let's say I need to take, I have a major sport event taking place in one area of the city. I can take some of the capacity that I'm not currently using in residential areas and shift that dynamically to entertainment areas, and I can shift that back whenever I want. And when you're turning up capacity, it is important as well to do this in a seamless and a timely manner. XR Optics has many automated features to accelerate service velocity, decrease troubleshooting times, features like remote diagnosis tools and troubleshooting, as I mentioned, embedded OSA. This is typically done with an external box. So that capability now is embedded into a pluggable form factor, OTDR, to pinpoint where the problem is. Ability to do loopbacks, remote loopback, power management, topology awareness, eliminating the need to dispatch many trucks after a failure. Quick fault isolation. So that allows a faster service turn up and recovery. This slide summarizes how XR Optics transform optical networks, especially in the metro and the aggregation space, by reducing CapEx and OpEx. I mentioned some of the case studies, so you can refer to some of the one of the case studies that we published with a tier one service provider in Europe last year at ECOC 2020. By modeling XR Optics on their real network, the savings came in the order of 76% reduction in total cost of ownership. Less transceivers, less aggregation devices and boxes and sites. The dynamic capacity allocation, being able to turn up capacity on the fly. There's that aspect of virtual transponder function. So in the pluggable now, you have functions that typically are offered or supported in a chassis form factor. So virtual transponder functions, automated and remote management tools, flexible management, bandwidth management, being able to do symmetrical and asymmetrical traffic flows, being able to deploy over virtually any existing fiber infrastructure, point-to-point, point-to-multi-point, fiber pair, single fiber working, fixed grid, flex grid, cascaded ROADMs. Those are pluggable optics that can be equipped in a wide range of host devices, switches, routers, FDM equipment, as well as the future-proof aspect, as I mentioned. That is absolutely key because now a network upgrade or a node upgrade does not trigger a network-wide upgrade. You can upgrade the hub from 400 gig to 800 gig while leaving the endpoint intact. And that's a future-proof solution and a maximum ROI. There are many system-level capabilities in the pluggable form factor, as I mentioned, in-band, out-of-band communication channels, wire speed encryption in the pluggable, control plane features, constellation, power management, optical spectrum analyzer, as I mentioned, and many others. And I want to just finish with the OpenXR Forum. So last June, the OpenXR Forum was founded to foster the collaboration between its members to facilitate the adoption and accelerate the growth of network architectures, leveraging that point-to-multi-point coherent pluggable transceivers. And the OpenXR Forum members focus on defining the compatibility requirements within host devices, creating the specs for open management interfaces, demonstrating interoperability, and many other focus areas. And all these initiatives will help accelerate the wide adoption and deployment of XR Optics innovative technology by a broad spectrum of network operators in a wide variety of applications. This is actually a slide showing the market momentum. XR optics is getting a very positive momentum, a very positive market reception. So I will not go through every single detail here, but we've been very busy conducting lab trials as well as field trials. You can see on the right-hand side where an XR optics in the back of a van, and the fiber is going into the manhole connecting to a customer's existing PON network. We've done a lot of techno-economical case studies as well, showing the savings in terms of TCO, CapEx, and OpEx, and so on. So if you want more information about XR optics, please go ahead and visit infinera.com. You see a lot of papers and articles and blogs that will help you get more information on the benefits of deploying XR optics. With that, thank you for attending the session and enjoy the rest of your day. Thank you.